Hello everyone and welcome back to the channel. Today we're going to be redesigning this terrible janky overhead camera mount that I use for my live streaming setup. So let's get started. So firstly, let's understand the problem. This camera is mounting to this boom arm, which is a little bit janky. It can fall out quite easily. So that's problem number one. The second problem is that I can't rotate it. So it's set at this horrible angle. If I do try and rotate it, it falls out. So that's problem number two. It needs to be able to rotate so I can get the camera aligned with the desk and everything looks nice and square. And that's pretty much it. Those are the two problems. So we need something that's secure and rotates. We're going to try and use this threaded camera mount, which is like the standard tripod thread thing. I can't remember what size it is, but I've got a little screw here which will fit it perfectly. So we're going to be using that to mount the camera to a 3D printed part, and then that part is going to hold onto the boom arm. So the first thing we're going to do, of course, is do a rough sketch to get an idea of the kind of thing we're looking for, get some of the key dimensions, and then we'll jump into Fusion 360, do a print, assemble it, and test it. So let's get going with this sketching. Now that we've got that sketch sorted, it's time to use Fusion 360 to actually model that into a 3D design so we can get the files for printing. So let's start doing that. Of course, once we're in here, the first thing to do is to save the part with a sensible name. So I'm going to call it webcam boom arm mount. That seems relatively sensible. We're going to start off by creating a sketch which we're going to extrude to the side. Now there are obviously a number of ways you could go about approaching this design, but I think this way will be nice and quick. It doesn't need to look really beautiful, it just needs to be functional. This part in the middle is where the boom arm is going to go, and this part is going to form part of the clamp. So let's put a rectangle around down here, and we're going to add in a quick construction line upwards and make this symmetric on either side. Not like that though. Wrong order. Line, line, symmetry. If we make this perhaps 40 millimeters across, and then that should give us some space for the screws on either side. I'm also going to add in a line here. This is going to be the thickness of the top part of this, maybe 3 millimeters. And then another line is going to be the thickness of the gap, maybe 2 millimeters. In fact, one's probably enough. We'll keep it at 2. And then this can come down, and we're going to make that tangent with the base of this. We can see now there is still a bit of movement, so let's do something sensible. Let's add in a short construction line here and make our gap symmetric around that middle line. So now we can go ahead and extrude out the shape that we need from this, which is going to look a little bit like that. And I think, let's go, I think 45 millimeters long, that's about the width of the body. So now we've got something that starts to look like a clamp. We need some screw holes, so let's start with those. Again, starting another sketch on this top face. We need that screw hole, but in 4 positions. So the strategy I like to use is to create a couple of construction lines. And then we'll use the mirror feature to mirror that hole across in the 4 positions, and that will ensure that they're all the same size and symmetric around these lines. So using the mirror tool, select the object and then the mirror line. And we can then just repeat that using the same tool, this time using both objects and the other line. These are going to be using M3 screws, so we're going to go for a 3.5mm clearance hole. Separation of the 2 holes we'll put at maybe 30mm. And then this hole we actually want in the middle of this face. So again, I'm going to add a construction line in here and set that midpoint, set the point of the circle, the center of the circle onto that line. Doesn't really matter where we end that point, somewhere along there. So that's going to create some clearance holes for our screws. So they should slide smoothly through here. Now we could set a dimension for how deep we want this, but at the moment, I'm going to set it all the way through the part. So using the all, that will mean that whatever dimension we change this to, that will always go all the way through. Let's have a quick save to make sure we don't lose anything. I mean, we probably won't, but just to be sure. The next thing we're going to do is add somewhere for the nuts to go. So I'm going to start another sketch on the top and set this up in basically the same way as the last one, with pulling in that reference geometry from the previous sketch and adding in a couple of construction lines, because we're going to use the same mirror tool to mirror these features. This time we're going to set a rectangle around here, so we're going to add in square nuts. These are going to go, well, these need to be about 5.65, and then obviously to the middle of this hole is going to be that divided by 2. 5.65 divided by 2. Now, we can probably just round this. This is 2.825, so I'm just going to make that 2.9. That should be fine. And then we can actually dimension to here as that divided by 2. That's nice. Now we've got this feature, again, we're going to repeat this mirror tool. Select here. To select all the way around, you just double click the lines. Mirror across this other line, and there you have your 4 nut slots. Now, obviously, we don't want to cut out of this face. So when we do our cut extrude, we're going to select all these shapes as before. We're going to select the whole thing, actually. We're going to cut the shape as an offset. So if we select offset, we can then move that down by, say, 7mm. Oops, daisy, I've hit numlock. Minus 7mm. And we'll cut that as about 3mm deep. So if we were printing this in this orientation, we would need some feature in here to make that more easy to print. I've done a video on that. It's quite easy to do, just a couple of square sketches. But in this case, we're going to be printing it on the end, on this face probably, or the other one, the other end, doesn't really matter. So we don't need to worry about that feature. I think this is looking quite good. The next thing we're going to do is make this bottom feature more circular. So we want something that's going to be rotating. So we also I kind of want that feature to be uniform as it rotates rather than to have square edges that stick out. So what I'm actually going to do is go back to the first sketch and edit this a little bit. I decided I don't want this tangent here. I'm going to pull that up a bit, and we're going to set that dimension at maybe 8mm. No, more than that. 10mm. I think that looks sensible, but you can see all those other features are still exactly the same. Now we're going to have a sketch offset from here, maybe 4mm. And on this sketch, we're going to have a circle right in the middle. And the diameter of that is going to be 45. So that should match the whole width, the length of the part, but not quite the width, which is fine. At this point, I'm also going to change the depth of these holes. Now I'm going to do a loft between this face, and that will give us the kind of geometry we want. But what I don't want to do is make a mess of it. So first thing we're going to do is reduce the length of these holes so they don't come all the way out the bottom. So instead, these are going to come to maybe 13 millimeters. So a 12mm screw will go through there nicely. In fact, we're going to pull this top face up a little bit. We're going to make this 5. And that's not great. So you can see I have a bit of an issue here. Where I've moved this plane up, and this was dimensioned from this plane, it's now cutting the top of this shape, and that's really not what I want. What I've done there is made a mistake. I've referenced those dimensions from the wrong point. So I'm going to modify this feature, and I'm going to change how this works. So instead of just offsetting a dimension from this plane, I'm going to go from an object, and we're going to go from here. And then we'll offset this by 2, and that will always then be 2 millimeters from that face rather than 7 millimeters from that face. That looks really good. So now it's time to do, I think we can do a loft from here. First profile will be the square, second profile will be the circle, and there you can see it's done a nice little loft between the two. Having had a little look at this shape, I've decided that this is obviously going to be overly challenging to print, and so I'm going to change the design a little bit at this point. We're going to remove this loft here. Although having a circular base would be really nice, I think it's a little bit over the top considering the time scale that we have to achieve this. So what I'm going to do instead is just have a square, and it's just going to have, you can then use the square to kind of set the dimension, and it's a bit easier to grip than a circle. So this isn't going to be too bad after all. We're going to change these dimensions so this goes back to something a little bit larger because we're going to need a bit more thickness in here, and we're going to add a screw in here. So taking a sketch on this face, starting a sketch on the base now, on the bottom. We're going to add a line in here for construction so we can find the center point and do another 3.5 millimeter hole. And this is going to be the hole that the whole thing's going to pivot. So this is just going to go through about 6, let's go 8 millimeters. In fact, what we can do is send it to this plane here, and that will always make sure it cuts all the way through that feature. Next, we need to add a counterbore feature into here. So we're going to put a nylock nut in that space, which will allow us to screw up into it and it won't come loose. But we also obviously don't want to tighten it down because that will prevent rotation. So again, we're going to start a sketch on the bottom face. This time we're going to add a hexagonal shaped hole instead of a square shaped hole, or circle shaped hole. I don't know why I said square. So the feature we want, where is it? Polygon, inscribed or circumscribed polygon, up to you. I'm going to set the dimension across the flats. Oopsie daisy. So across flats for a hex is about 5.65. Same as it is for the square nut. Now that we've got our shape, we need to cut it out, obviously. So let's do that. We want to offset from the current plane by a couple of millimeters to make sure it doesn't come loose. And then we need about 4 millimeters of cutting. Oh, why is this? So we need that to be -4 and this to be -3. So here I'm a bit concerned that the nut's going to actually come up into here. So we don't want to do that. I think this is going to have to be much shallower. -2. Let's make this -6. Hopefully that will give us enough depth to have the hex nut fully recessed below that edge. I've just grabbed a nylock nut quickly, and that's about 4 millimeters tall. So we need to make sure that we've got 4 millimeters of depth in here before it reaches, and we don't quite, 3.9. So if we just set this a little bit shallower, what we're going to do is make this 14. That's good. And then now we should have 4.9. That's absolutely fantastic. So now we'll have a nut in there, the screw will come down the bottom, and that's going to be fantastic. So now we need to get going with the bottom half of this design, which is going to be the part that actually is touching or holding the camera. To do that, we need to start a new sketch. So this is going to be on this plane here. And of course we need it to be offset from this part. And we're going to just offset this line by 0.4. It doesn't really matter here how much you offset this line by, purely because they're two separate parts. They'll be printed separately. So at the end of the day, they're all going to be joined up. It doesn't really matter. But for now, let's put in some geometry to get things kicked off. So I think this is about what I want this part to look like. And this is going to be going all the way. So we can set our extent to this face. And then we need a hole in this place here where the big screw thing is going to go. Now, there is two ways of doing this. In my sketch, I put this like double-sized hole, so you can put this in and then like move it and then it won't come out, but I'm not sure if that's going to be really necessary. I'm just going to go with a straight hole and then the head of the screw will still hold it in place nicely. So that will make things a little bit easier to design. So we're going to start with this hole on this face. So to make sure everything's aligned, again, I'm just going to use a nice construction line down the middle. And then a circle. I don't want it in the middle of the line this time because I need to dimension how far down it's actually going to sit. Now, we measured this at 25 millimeters, so I'm going to put in 26 to make sure we've got a bit of room. And you can see immediately we've got a problem. That's not a major problem. We can fix that with our parametric design. The size of the hole is going to be 7 millimeters. So we're not going to worry too much about that sketch for now. Let's go back to the first one and add in some dimensions here. So maybe this can be about 7, but this needs to be much longer. In fact, we're going to need a measurement off the camera. This is going to be, we're going to set this around 45. Okay, you can see again, we've got problems, but that's easy to fix. Make this maybe 5 millimeters, doesn't really matter too much. Because there is some thickness to the body of this camera and I want it to be central, I'm going to actually just quickly measure the thickness of that. And that's 11.5 mil. So I'm going to dimension to the middle as 11.5 divided by 2. And that will give us a nice little offset. 11.5 divided by 2. I reckon that looks fantastic. So now you can see that hole is much better positioned where we expected it to be. We can cut that all the way through the shape. But of course, at the moment, this is all slanted, so let's start another sketch and we'll create a counterbore for the head of the screw. This we measured at 14 millimeters, so I'm going to make it 15. In fact, let's give us ourselves plenty of room and make it 16. Now, the minimum clamp distance was 4.73 millimeters, so this offset needs to be at least 5.5 minimum. So if we have an offset from this plane, we need to go, I'm going to go -6, and that will make sure that we're in a good space for that. And then distance is going to be all, but we need to change that direction to be the other way. There you go. You can see it's not made a huge difference to that geometry, but that will give us a nice face for it to clamp on. Now, of course, we need a way to mount the top to the bottom. At the moment, we don't have one. So what we're going to do is start a sketch on this face and convert the sketch from the other body. And why is it doing that? Project that onto our current sketch, show our body again, and there you go. So we can now cut this all the way through. I'm going to do all, but I'm going to constrain it to only be body number 3, so it won't go through that top, as you can see up there. Just goes all the way through this particular part. Now again, we want to be careful about the screw length that we're using. we don't want this screw to go all the way through, so we're going to have a counter bore here to monitor how deep this screw is going. So first thing to do is to measure up to here, which is about the extent of the screw. That's about 14 millimeters. Now we have 12 millimeter screws, and that's probably going to be about right. So if I do a counter bore of about 2 millimeters, that will give us about what we need. So if we create a sketch on that face, right over that hole, counter bore needs to be just slightly larger than the head of the screws. So we'll put it at maybe 6 millimeters. And then we'll cut that down by -2 millimeters. So that will give us somewhere for the screw to go. That locks into there. We don't tighten it too much, and then we should have some ability to slide the two parts between each other. So now we can add any additional features we want to make this maybe a little bit easier to print. I'm going to print this on this face. I'm going to print this on that face as well, I think. And then this one I'm going to print also on that side face. So we can probably print them all in one go, to be honest. And they'll all be printed on this side, and that should just about work. One thing I have considered is actually moving this hole down a millimeter or two, just to make sure we've got clearance from the head of this screw up here. So take this and move it down. I'm going to move it down 2 millimeters. It's not going to affect any other geometry. The width is the same. This will be very slightly different relative to the part, but that's not of too big a concern to me. So again, we're going to save that. That's at version 3 saved, and let's get this saved as an STL so we can print it out. To save an STL, right click, save as STL, find the location that you want to save it in, and then obviously hit save. Seeing as the physical loading on this part is going to be fairly low, the material that we use to print it out of shouldn't be too much of an impact on the final design. Temperature-wise and strength, it's all fairly easy going. So what I'm going to choose to do is print it out on the Lotmax SC10, which we've got just here, which you can't see. I just finished that last night, so that's going to be the ideal printer. It's set up and ready to go. So as you can see, I've got my profile here set up for the Lotmax SC10 PLA, 0.2 millimeter profile. So as you can see, we've imported this as a single part that has 3 bodies. That's not ideal for us. It'd be much easier if this is just 3 separate things that we can move about the build plate individually. So I'm going to come in here and go split to objects. And there you go, that's immediately fallen into 3 different objects. So now we can set our orientation for each of these parts individually. Up on the ends like this, arrange them on the build plate, looking a little bit like that. Now we can hit slice and we'll save it to an SD card and start the print. Okay, so we've finally got those parts printed. It took about 3 hours for this larger design, but I've also done a slightly thinner design, which took about an hour and a half. So that's a little bit narrower. Should work pretty much exactly the same if it's something you want to try, but I'm going to go with the thicker design as that's obviously what I designed initially. So let's do a quick assembly then. We've got all the parts here that we need. So we've got obviously the camera itself, 4 M3 by 12, well 5, 4 for the top and 1 for the middle, the screw to mount to the camera, a nylock nut and 4 square nuts. So let's first take this part and insert the 4 square nuts. These seem to fit just about perfectly, which is lucky. Well, it's not lucky, it was deliberate, but it's still good that it does all fit first time. I'm just going to push these into the hole carefully with a pair of tweezers. They are quite a firm fit, well, quite a snug fit, so they shouldn't fall out, which is nice. The next thing to do is to add the nylock nut into the top, so that can just sit in the top there. You can start, oh, there we go, it's settled in completely by hand. If you try this and it can't get it in, you may need to use a screw from the other side just to pull it in, but that one seems to have gone in just nicely. And again, doesn't fall out from light shaking. You could push it out if you wanted to, but generally that's pretty well stuck in there now. So then we have this part which goes on the base, and this screw will go up into the nylock nut that we've just added in. That works reasonably well. Again, it stays in place as it is, but you can also rotate it to any position that you want. Over time, this is bound to wear out if you do a lot of rotation, but you could just tighten the screw a little bit more, or you could tighten it a lot and then it would all just stay in place and you wouldn't have any rotation at all. But overall, I think that fits rather well. So let's see if this camera fits. So we've got obviously this hole matches up with this, and then this screw goes gently on the back. And there we go. I'm really happy with how that's turned out. That assembly's gone really well. We've also now just got the clamp, so that's got to go up here. Let's try it out and hope that it works. It's not very often that I choose to stand up on camera, so a bit of a treat for today. Let's see if this will clamp on here nicely. That looks like it fits reasonably well. A couple of screws down through the top. These are just standard M3 by 12 screws. There's really nothing special about them. My only concern at the moment is the weight. If it's a little bit too heavy, the whole arm may just tip over, and that wouldn't be great. That would be another reason to go for that slimmer design. That seems to work reasonably well. And we can rotate it so the camera can go at basically any angle. That works actually really rather well. So I guess all that's left to do now is to evaluate how well it works. Well, if we take a look at the camera, hopefully you'll agree, I think that's pretty good. Everything's kind of square, you can see these lines on the table. I can line it up exactly how I want. If I want to rotate it a little bit in one direction or on the other, that's really easy to do. The arm's still nice and sturdy. It's really quite happy holding that weight. It's not very much extra, so that's absolutely fine. The material selection of PLA seems to have turned out just fine. If you tighten down the screws a little bit too much in the clamps, then that could be a problem, but being careful overcomes that quite easily. All that's left to do now is some durability testing, which of course means a live stream. So I do my live streams on Sundays at 7 PM. That's kind of British Standard Time, but will change when we change to GMT. It's normally 7 PM my time. So that's going to be it from me today. Hopefully this video has been really useful for you. I know it's been quite a long one, but I think there's quite a lot of detail we've got in there too. We've obviously gone through that whole process, as well as a really big focus on that Fusion 360 design process, how I'm modeling that whole thing beginning to end, so you get a whole idea of where things can go wrong and where you can make mistakes and jump back in your timeline to make corrections and updates, or even change your ideas. Very slightly diverging from where your concept sketches started, but still coming out with a result that's exactly what you're after. So that is it from me today now. Thank you very much for watching, and I'll see you in the next one.